This is the f of x function. Explain why this has no inverse. Well, the definition of a function, of course, is that it passes the vertical line test here. If we make an inverse of it, then we also need to make sure it passes the horizontal line test. So clearly it doesn't pass the horizontal line test. So you can actually just state that does not pass the horizontal line test. And also you can think about what type of function it is. This 4 here goes to this particular output here, but this value of 2 here also seems to go to the same output here. So we've got many to 1. So that's another way of saying the same thing. We've actually got a many to 1 function. So clearly if we take the inverse of many to 1, it actually turns into a 1 to many. That's another way of thinking about it, that the inverse of this, we can certainly draw it, but it'd be an inverse relation, but not an inverse function. Okay. Number 2, the domain of f is restricted to define a function g, so it has an inverse g to the minus 1. State the largest possible domain of g. So we need to try and restrict this so that when we do actually do the inverse, we actually define it as a function. So I mean this should help. We need the horizontal line test to work for the existing function f. And if you think about it, the maximum value is here, the minimum value is here, and we've already had those particular values defined. This was -1, -1. This was defined as 3, 1. So if we restricted the function from here all the way down to here, can you see that this particular restricted function is a 1-to-1 function now? So when we take the inverse, it'll also be 1-to-1. So I think that the largest possible domain of g is the fact that x is less than or equal to 3, but greater than or equal to -1. Okay. So now we'll finish off and we'll just try and sketch on the same axes, sketch g to the minus 1 of x. Okay, well, you realise that this 3, 1 here, and this point here, -1, 1, those are the endpoints for our g of x. We've got to sketch the inverse function g to the minus 1 of x. So I'm just going to put a few more points on. This is 1, 0, and this here, that looks to be 0, -0.8 by the looks of it. Okay, it looks like this is drawn to some sort of scale, so we could put y equals x line in here. That might help in terms of the structure of the answer. Okay, so this would be the line y equals x, and we know that the inverse is a reflection of this line. 3, 1 here becomes 1, 3. 1, 0 becomes 0, 1. And the point here is actually on the mirror line, on the reflection line, so it stays on the reflection line, yeah? -1, 1 becomes -1, -1, sorry, becomes -1, -1, stays where it is. Okay, 1, 0, 0, 1, and this one here, 0, -0.8 becomes -0.80. So we've got a sense of how to construct this curvature one way, and then a point of inflection goes the other way. So curvature one way, and then looks like a point of inflection, then it curves the other way. So that would be the inverse function g to the minus 1 of x.